Hello, everybody. Welcome to this webinar about Kotlin. My name is Pavel Kulik. I'm a Java developer at VMPL Software House. And as a brief introduction, I'm going to be talking about Kotlin for around 55 minutes. This is the first webinar in a series of events which will be held at VMPL, where developers will be sharing their precious bits of knowledge with you. And the first topic we chose is about Kotlin. So the title of the webinar is 10 Years of Kotlin, an introduction for an experienced Java developer. The idea of this talk is to give those of you who haven't had the chance to experience Kotlin yet, a condensed knowledge bill about what Kotlin is about, what Kotlin is like. And I will divide this talk into three parts. So the first part will be talking about the state of Kotlin. So I will talk about what it looks like on the market right now for Kotlin. Second part will be a live coding demo. And at the end, I will be talking about the reasons why people are hesitant to adopt Kotlin, and we'll discuss a little bit about that. But let's ask the first question. What is Kotlin? Because some of you might even not know. The first time I gave a talk like this to my colleagues around 4 years ago, I was very excited about Kotlin, and I decided to introduce it to my colleagues. I called it the next big thing in the Java world. I don't think it's fair to call it the next big thing in the Java world anymore, because Kotlin is 10 years old today. Well, 10 years old this year in July. The idea I want to present, the argument I'm going to make, is that Kotlin is maturing as a language. It has matured quite a bit in the last couple of years, and I will try to present data to support that claim. I will also try to show you some data about how its development and how its adoption has progressed well in the JVM world. So, but seriously though, if you don't know what Kotlin is, Kotlin is a statically typed language from JetBrains. So the people who create IntelliJ IDEA, ReSharper, many other great IDEs and tools. It is a language that's basically supposed to work as a drop-in replacement for Java while trying to fix many of Java's shortcomings. The main idea is that it should not try to upend and change every paradigm that we are used to from programming in Java. The idea is that it should be easy to adopt for a Java developer. And while doing that, it's trying to fix some of the design problems and just be all around a nicer language to work with. As such, it compiles to JVM bytecode. It can also compile to JavaScript and a native Kotlin target, but we'll focus on the JVM bit. And one of its main selling points is a deep interoperability with Java. So Java classes and Kotlin classes can be used together in a project, including applications which work with annotation processing. So Spring, Java EE, Quarkus, Akka, what have you. This stuff works with Kotlin as well. And it does enjoy great backing by JetBrains, which is a very, I think, reputable company, and also does a great job in making the language accessible and to sharing its direction with the community. This is a graph of the searches for the term Kotlin in Google Trends. If you look at it, there's a big spike in 2017, and that's no coincidence. Actually, I think that's the moment where Kotlin really entered the mainstream programming, I would say, public opinion, and it happened at the Google I/O conference when it was announced that Kotlin would become a first-class development language for the Android platform. To this day, Android remains one of the main use cases for Kotlin. If you're an Android developer, I probably don't need to introduce Kotlin to you. You can see that the popularity has risen quite a bit since then. It is not anymore, what I would say, on a hype curve, so it is not rising anymore so much, but the number of developers of Kotlin is steadily growing. Some other piece of data I would like to show you is the adoption of Kotlin in the Stackoverflow developer survey. So one of the biggest surveys there is about the habits and languages used by developers. You can see that 2018 had around 4.5% of developers claiming that they had used Kotlin in the previous year. 2021 is around 9% of people who claim to have used Kotlin. Meanwhile, the percentage for Java has dropped a bit, and the sum of the two has also dropped a bit, which is not unexpected, because most Kotlin developers will actually use Java as well. It's probably not an exclusive set. So you can see that the popularity has grown quite a bit. 9% of developers claiming that they have used Kotlin in the past year is not bad at all. Some other data about how Kotlin has grown in the couple of years. 2017 had around 40K GitHub repositories. 2021, 160K GitHub repositories with Kotlin. If you look at the use cases that Kotlin has, 63% of people claim that they use it for Android development, server-side development, not far behind, and other use cases are much more niche. As I said, Android remains a big niche for Kotlin, although server-side development is also quite big and is gaining in popularity. Some other data. Actually, JetBrains publishes a lot of data about the state of Kotlin. If you're interested in that, there's a lot of reports and this thing called a Kotlin census on their website. You can check it out. An interesting piece of data I found is the how long have people been using Kotlin, and you can see how the responses have changed over the years. 2018, most people had been using it for less than 6 months. You can see that in 2021, there's a growing community of senior developers in Kotlin, so people who have used it for between 2 or 4 years. Actually, quite a few people have used it for more than 4 years. I think it also goes to show that the people who adopt Kotlin tend not to drop out of it. I think this progression is quite natural if you look at it, which means that Kotlin has stayed in the places where it got its foot in the door. And another interesting metric I would like to show about Kotlin is the love of Kotlin. So the Stackoverflow developer survey has this great question where they ask whether you love or hate a language, and it's binary, so no room for nuance there. But anyway, 75% of people claim they use love Kotlin in 2018. 2021, 61% of people claim that they love Kotlin. So it dropped quite a bit. I think it goes to prove that Kotlin has matured in the way that more people have gotten the trenches with it and discovered its bad sides as well. You can see that for Java, the decline is also there, but it's a bit less significant. Who is using Kotlin? 1,023 companies on Stackshare, last time I checked, versus around 10,000 for Java. So, well, not bad, I would say. As I said many times before, main use case is of course Android development. Some companies you might know who use them, but I just picked two quite randomly, Revolt or Tinder. Pivotal is a big player in the Kotlin scene in that they have been adopting Kotlin for server-side development and supporting it for Spring Boot. Spring Boot totally has first-class Kotlin support these days. Most code examples are translated into Kotlin on the Spring documentation side. So, and they've also been pushing quite a bit to translate their code base into Kotlin. So, they are one of the drivers behind its adoption. You might have heard about Google, the company. I don't like to cite personal anecdotes, but I like to quote this one. So, Google, one of the Google products, which is Google Home, the team behind it claimed that since they started developing new features with Kotlin, they did see a 33% decrease in null reference exceptions. And you might wonder why is that? And that leads me very nicely to the introduction of the language itself, because so far I've only been talking about the market, and you might be interested in what this language does to make it so great. So what does Kotlin have that that makes it better than Java, probably? That's a controversial statement, of course, but I will talk about some key things. So I think the most important thing that they sell is the null safety. So basically, Kotlin has the handling of null values built into the language, very deeply into the language. You have to handle, in Kotlin code, you have to handle null references at compile time, which does, in fact, limit the number of null pointer exceptions you will get. So it is really built into the language at its core. It is not something like the optional in Java, which is a way to solve the problem, but is not baked into the language. Instead, it really forces you to think about the handling of null values at compile time. So that's one of the biggest selling points of Kotlin, null safety. Then ifs, try catches, and whens are like switches in Java, are expressions. So Kotlin buys into the functional programming mindset, into the kind of immutability mindset, which results in the fact that, well, most blocks in Kotlin are expressions, I think, if not all, which means that you can assign a value to an if block, to a try catch block. You don't have to do the whole dance in Java with creating a variable and assigning it inside of a try catch block so that it's available outside of it. So that's pretty neat. You have extension functions, which are functions which you can add to classes that you cannot extend, like strings, integers, big decimals, and they can be useful in your code base. Var and val keywords. So I think var I don't need to explain. Val is an immutable var, so nice short syntax there that encourages the use of immutable references. Inline functions, name function parameters, so nice self-documenting features. If you want to call a function which has a lot of parameters, you can actually explicitly name the parameters, the values as you pass them. You can return multiple values from functions. Semicolons are optional, apparently, so that you can argue about whether they are needed or not. Well, there's a lot of functional programming constructs, so stuff like higher order functions, etc. There's a very powerful collections library that uses these things quite a lot. This is a thing that Kotlin This is a thing where Kotlin is a bit opinionated, where they do want you to buy into the functional programming mindset a bit more than the classical object-oriented programming from Java. We have smart casting, although it is in Java as well these days. Data classes, one of my favorite features. So it's very easy to create data classes. So classes which are basically containers for values. You have no checked exceptions, so that's done away with. I think quite a popular design choice in Java. You have operator overloading, so you can define your own operators for your classes, and that's basically just scratching the surface. Kotlin has lots of features, really lots of features, and it's impossible to name all of them in a short presentation. And reportedly, people say that they get advantages out of using Kotlin. If you look at the testimonies of the blog posts, people claim that they get less null pointer exceptions, and their apps are more stable in general. You have more concise and expressive code, which means less time is needed in code review, less time needed to develop new features. And the developers are more enthusiastic because everyone loves a new toy. So let's switch to an IDE actually, and let's start writing some Kotlin. So I will show you some basic features of Kotlin. Of course, as I said, I'm not able to introduce Kotlin fully to you, but I think I can do enough to get you interested in the language. So let's start by creating, that's an empty project basically in IDEA. If you want to write Kotlin in IDEA, you have to get the Kotlin plugin. But yeah, basically IDEA is the go-to IDE for writing Kotlin, as you could expect. Let's create an empty file and let's call it program.kt. And let's write a hello world, shall we? So I'm going to write function main and hello world, exclamation mark. All right, that's it. I can now hit compile, and I can run this program, and this is a functioning Kotlin program. So the first difference you can see from Java right away, I did not need to use a class to write a main function. So Kotlin supports and embraces top-level functions. You do not need to put functions inside of classes if you don't want to, just for the sake of it. So that's a pretty simple hello world. But let's actually create a more sophisticated application. Wouldn't be very sophisticated, but enough to demonstrate some of the points I want to make. So we will be writing a bookstore, because what else will we be writing? And for that, we're going to need two classes at first. So we're going to create a data class first. We're going to create a data class called book, and this data class called book will have four parameters. So it will have an ID called string. Well, it will have a string called ID. It will have an integer called pages. It will have a title, also a string, and it will have number of pages, which is an int. And basically, I just declared a full-blown data class that can hold values for me. It will have all the getters and setters available in Java. I will talk about that a bit later. It has equals, hash codes, toStrings, what have you. This is all automatically generated. That's very powerful. Actually, what I did to declare these things is I used the val keyword. The val keyword means immutable, so these are read-only values. And you can see I declared a type, which is declared that way. So a colon followed by the type. So that's takes a bit of getting used to if you are coming from Java, because you declare the types differently. But yeah, that's very short as a definition for data class. So I can go back to my main function and I can create a book. And I have a default constructor, which takes all the parameters, of course. And so I'll go and I'll create a book, ID 1, give it 100 pages, title is Harry Potter, and number of pages is 100. And there you go, I just created a new variable. You can see that there is no new keyword. I did not need to create to declare the type of this variable. So it got automatically inferred. Of course, this is not dynamically typed. This is all statically typed. It's just that you don't need to declare the type, but you can if you want to after the colon. But you need to remove the but you can remove the type declaration. It's not necessary. All right. So let me create another class, and this time it won't be a data class. It will be a class that holds logic. And let me call it bookstore. So I'm creating a class called bookstore, and this class called bookstore will hold a variable called books, and books is going to be a list of books. So straight away, Kotlin is complaining. It is not allowing me to do this. The reason is Kotlin by default does not allow you to declare variables which are not initialized. So you have to do either of two things. So you either declare it as late init, but we're not going to do that. So this overrides the default behavior. But what you can do is you can just initialize it, and we'll initialize it as list of. And list of is just a way to initialize a list, an empty list. So we can go back to our main, and we'll initialize a bookstore and say bookstore is equal to bookstore. And we're going to try to add a book to the bookstore. So we go bookstore.books.add book. And would you look at that? It's not possible. So you cannot add a book to a bookstore. Well, a book to a list of books, actually. And why is that? The reason for that is that collections by default are immutable in Kotlin. So if I want to add something to a list, I need to actually declare it as a mutable list. So I'll go mutable list of book equals mutable list of. And now I can add something to the list. Another way of doing this would be the immutable way. So I'll just say books.books. I'll create a new instance of this list. And I'll just say books.books plus 1. So plus book, of course. So yeah, basically that's a thing that Kotlin does differently already. Just added a bunch of books to the bookstore. By the way, trailing commas. Nice. So we're going to write some functions actually, and I'm going to show you how Kotlin does functions. If we go to the bookstore class and let's try writing a simple function. So a function called get total number of pages in books. So I'm just going to sum all these values and see what it works out to be. So get total number of pages in books, and this returns an int, of course. And I'm going to return books, and then I'm going to map a book to the number of pages it has, so book.pages. By the way, Kotlin does not like get pages and set pages, getters and setters. These things are done away with, although there is something done to ensure interoperability with Java. So you don't write get pages, set pages, it's just books.pages. So I go books.map and I will sum all of them. And voila, now go to the main function and I can call this function. So I'll say total number of pages equals bookstore, get total number of pages in books, and I can print it. I'm printing it, and it's 1,190. Seems legit. Kotlin actually lets you write more concise functions than that. That's the Java way. So what we're going to do is we're going to replace this lambda with a simpler version. So actually, if you have only one parameter in a lambda, what you can do is you can implicitly refer to it as it. Maybe it's clearer if I just show it. So instead of writing book arrow book pages, you can just write it.pages, and it's actually simpler. And you may have noticed that this is just a simple expression. So Kotlin actually doesn't require a body in a function like that. You can just return an expression from a function like that. So you can convert it to expression body. So that's what it looks like. Basically just an equals, and actually, since Kotlin can infer the type of this expression, we don't actually need to declare a type. So that's pretty easy, and that still compiles and it still works, and we have made our code quite a bit shorter. Let's try something else. Let's get all the books that are not in stock. So all books not in stock, and this equals books.filter it number. Oh, I made a mistake because this is not called number of pages. This is number in stock. See? Okay, it number in stock is less than 1, and there you go. We can call it as well. So we can say val books not in stock equals bookstore get all books not in stock, and we can print this list. And another thing you may notice here, this is automatically a list. I did not need to go over the whole dance I would have to do in Java with streams and collectors. Kotlin is quite reasonable on that. If you're filtering a list, it actually returns a list. So this is nice and concise. All right, let's talk about the nullability thing, because I did mention that nullability is a major selling point of Kotlin. So let's actually try and add a null value somewhere. So we're going to copy this this value, and let's say pages are null now. And as I promised, Kotlin does not allow null values and non-nullable types. So basically, this doesn't compile, and the reason for that is that pages is an int. And by default, types in Kotlin are not nullable. So if I want to make them nullable, what I have to do is I have to add a question mark. And this is now a completely different type that has to be handled appropriately. So you can now notice that I am allowed to add the null value as the value for pages. But well, so something else broke. So I cannot add, well, I cannot sum over pages right now. And the reason for that is that pages can be null. And Kotlin is already aware of that this can cause a problem. So what it will do, it will force me to handle this null value explicitly. So since I know that pages is nullable, I have to tell Kotlin what to do in case it's null. In that case, I'll just say if it's null, I would like have a 0. So this operator, what it does, it takes the left side, and if the left side is null, it returns the right side. Otherwise, it returns the left side. So basically, it says it.pages or null. Well, it says it.pages or 0. And I can call it now, and it will work the same as before. Another example, so we can write a function called get all titles uppercase. And we'll go books.map it.title to uppercase. And we can call it, so we can say all titles uppercase is bookstore.get all titles uppercase and print it. And you can see that I'm getting all the titles uppercase, as I would expect. If I now go to the book class, and if I change the type to string nullable, it immediately stops compiling. So I get this squiggly line, and it says, well, the same as before. I have to handle the nullability at this point. So since if the title can be null, I can do one of two things. I can either use a null save call. Basically, what this does is if it.title will turn out to be null, it will uppercase the whole thing. It will not uppercase the whole thing. Instead, it will return a null from the entire expression. So that's neat. This way I don't call a function on a null reference and I don't give an exception. If I am actually sure that it will not throw an exception, I can do this. So I can use the null asserted call or the double exclamation mark operator. And that's basically the only way to get a null pointer exception in Kotlin, in pure Kotlin, is by using this operator. It is intentionally made to look very aggressive, very out of place, because, well, you shouldn't really use it, because this just means, well, punish me if I'm wrong. So we can now change the title of one of the books to null, and we can run it. And you can see I did get a null pointer exception. So I can fix it by either doing this. And now you can see I have a null value in my return from this function. And actually, I can do a similar thing. Since this entire thing turns null now, I can apply the same operator as above. And I can just say that was null. Yeah, so basically I can apply this operator. And in this case, if this goes to null, that will be returned. And I can run it again. And voila, that was null. It's coming out. So basically, that's the handling of null values in a nutshell in pure Kotlin. Right. So there are other great features, and let me actually go back to the main function. So, for example, string interpolation, simple things that Kotlin does that are convenient. String interpolation. So what I can print is I can print the size of books is bookstore.books.size. No, bookstore.size. And you can see that's a pretty convenient syntax for nesting variables inside of strings. I can actually turn it quite easily into a multi-line string. So I just go and use a triple quotation mark, and yeah, and then I can multi-line this whole thing, and it's nice and concise and expressive. So yeah, a simple thing that is very useful. As I said before, the collections library in Kotlin is crazy powerful. For example, if I just want to return a random book from the bookstore, so I just say get random book. How easy can it be? I'd say that's quite easy. If you want to do this in pure Java, this is of course not so easy. Kotlin has lots of these functions that, so if you just look at what you can do to a collection, I mean, the list is mind-blowing. Most of these things are quite aptly named and they're quite easy to understand, but some of them aren't, of course. But in principle, well, the collections library is really powerful. For example, as well, if I wanted to, instead of summing these things, if I wanted to draw the average, or if I wanted to draw something else, Kotlin probably, if you think about doing this, Kotlin probably has already a function built into the collection library that allows you to do some manipulation quite easily and without much hassle. If we go back and we try to return two random books, so I get a function called two random books. What I would do to return two random books in Java is probably some kind of collection or list or set or something. Kotlin allows you to return multiple values from a function. So I'll just go, it's equal to pair of get random book. And I can now go here and I can say val first book, val second book equals get two random books. Books or get two random books. And I can print first book, second book. And let's actually show you the string interpolation there. So I can go this and this. That's a pretty neat feature as well. So if you want to simply return two values from a function, or actually more than two values from a function, works as well. You don't need to create a container just for the sake of it. What you can do is you can easily return two values, and then on the receiving end, you can easily destructure the result. So I just have to go val first book, second book. If I didn't care about one of the return values, I could just do this. So replace it with an underscore. Of course, this works not only if the two things are at the same time. So I can just write a function called get two random things. And I can say return a pair and a pair of 1 and ABC. And I can destructure the result of that as well. So I can go bookstore, get two random things, and I can print first, second, and you can see I did get the two values back. So another convenient feature. Actually, let's write another function to just show you one other feature. So I'll write a function called get all books in stock. Get all books in stock, and this function will in turn take a parameter. First time you write a function which takes a parameter, and the parameter is called min stock. So in order to assume that a book is in stock, it has to pass a threshold of minimum stock. So basically, we just go books filter it.number in stock is greater than minimum stock. And that's quite easy as well. And I can call this function, so let's do it. I'm saying books in stock is equal to bookstore, the books, get all books in stock. No, get all books in stock. And I have to pass a value, so I'll pass 50. I'm printing books in stock. Nice thing that Kotlin allows you to do. Firstly, you can name the parameters. So we can imagine that this function is considerably longer than one parameter, so it has a larger definition. What I can do is I can call it like that. So I can say bookstore get all books in stock of min stock equals 50. That's the same thing as the parameter scope. And yeah, that's a great self-documenting feature, and makes, of course, you don't have to call these things in order if you name them. So that makes the use of functions quite a bit more convenient in Kotlin. What I can also do is I can give it a default value. So I can give it a value of 50. And now, lo and behold, I did not have to pass a parameter at all. And this is still a function that takes a parameter, but the parameter has a default value, which I declare like that. And yeah, if I want to pass the parameter, the value of this parameter, I still can, but I don't need to if I don't want to. So that will save you a lot of typing if you just want some variations of a same function. If you want just slightly different sets of parameters. We're going to rate some books, shall we? So we just go rating, and we'll rate the books based on the title. So we'll go rating when, let's actually get a book first. So let's say book is equal to get random book. When book.title, and this is like a switch expression in Java. So we would go when book.title. So if it's Harry Potter, rated 5 out of 5. Not Harry Potter gets a 3. Else 1. So the syntax is a bit different here, but you can print the rating, and basically I just assigned a value to the the value that was returned from a when expression to a variable. Java can do this as well these days, but Kotlin is quite nice in that regard. Okay, so let me actually show you the interoperability with Java, because that's another major feature. So I can go and create a Java class. I'll call it comic book, and this is the Java class now, so you have to be careful. And I will return a function here that's called get comic book exclamation, and this exclamation, and this returns I'm a comic book, simple function. So I can now go to Kotlin and I can create a comic book. So I can now say file comic book equals comic book, and I just called this Java class from Kotlin code. And I can actually refer to this function. You can see that Kotlin does a mapping. So this function is called get comic book exclamation. So that's a standard getter function. What I can do is I can call it from Kotlin in the Kotlin idiomatic way. So instead of calling get comic book exclamation and writing parentheses, I can just refer to comic book exclamation. Actually, if I went to Java, and if I try to create a book, so I'll say final book equals new book, and pass all the parameters, of course, title and 100. I can actually get all the attributes from that class via the normal getters I would have in Java. So Kotlin generates these things for me. You can see I have no setters here because everything in the book class is immutable. If I change, for example, the title to be mutable, so I do it with the var keyword, I can now call a setter and set the title. So basically, that's your interoperability with Java in a nutshell. Kotlin classes work in Java, Java classes work in Kotlin. Last thing I'm going to show you is the reference comparison and equality comparison. So let's get a book from above, and I'm creating a book. First book equals this. So you can see the entire declaration, and let's copy it over and let's say second book. And let's print first book equals second book. So these things are, well, the same by value, but the references are different. So if you are used to Java, you expect this to return false, actually, because the references are not equal. But they are, in fact, equal in Kotlin. And the reason is that this operator, by default, compares the deep equality. So if I change pages to 101, this is now this now is not this now returns false. If I want to compare actual reference equality, I use triple equals. So it might be a bit confusing if you're coming from JavaScript, but that's the way it works. So double equals deep comparison, triple equals reference comparison. All right, that's about everything I have time to show you. Of course, I don't have the time to get in depth into all the Kotlin idioms and all the things that Kotlin does different than Java and all the things that Kotlin does better than Java, in my opinion. But of course, there's a lot of learning material if you're interested in seeing what Kotlin does and help you write more concise and correct code. So let's actually go back to the presentation. And I'm going to kind of change the mood a bit because so far I was very enthusiastic about Kotlin, but I'm not here to push Kotlin to you. I'm not selling Kotlin. No one's paying me to do it. So you might ask yourself the question, if Kotlin is so great and if people have these measurable advantages coming from using Kotlin, why isn't everyone using it yet? And apparently JetBrains asks themselves the question. So they publish a list of reasons for not adopting Kotlin. Apparently the most important reason why people are not adopting Kotlin is that they don't know about Kotlin, which is a great thing to say if you're selling the language. But of course, there are other reasons. So the things that they list is some of these things, some of these reasons for not adopting Kotlin, in their opinion, are quite legitimate. I would say some of them are a bit less, and some of them are just repetitions of the same thing. So, for example, the fact that people lack Kotlin skills, the fact that the adoption of the language is low, which actually goes hand in hand with the weak ecosystem. But there are other arguments that people have against using Kotlin, and I tried to come up with a list of those. So one of the main arguments is that it's very tied to JetBrains. So basically, the Java, the JVM ecosystem is traditionally kind of conservative, I would say. And people don't like the fact that this is tied to one company, basically. So all of Kotlin is tied to JetBrains. Of course, there's the backing by Google, but some people say that Google's attention span is very short. So that's one of the reasons why people are kind of hesitant to base their strategies on Kotlin, because, well, what if JetBrains decides that this project isn't worth it anymore? Are there enough people to carry the torch of Kotlin beyond JetBrains? Tough question to answer. Now, there's the question of the performance and the question of the compilation times, and that's a tricky question. If you look at the benchmarks, if you try to benchmark the Kotlin performance against Java performance, it is quite a bit convoluted in that in some cases Java will perform better than Kotlin, in some cases Kotlin will perform better than Java. For example, compilation times are slower, but if you use the incremental compilation that the Kotlin ecosystem makes quite easy, it can get faster. So I'm not going to say that Kotlin performs worse than Java or that it compiles slower in all cases, although this can definitely be the case. So if that may be your case as well. So that's why some people are hesitant to adopt Kotlin. Other arguments that come up: smaller hiring pool. So Kotlin is apparently a language that is supposed to be easy to transition from Java, but it is not always that easy, of course. And the truth of the matter is that the number of people who can write competent Kotlin is a lot slower than the number of people who can write Java. This can be a major issue for some companies, of course. Of course, there's another side to this argument, which is basically that since many developers are very enthusiastic about Kotlin, as you would find quite easily online, and they are coincidentally the same developers who are eager to adopt new technologies, that hiring developers who are willing to learn Kotlin is actually a good thing for you, because you will get the talent that is not hesitant to learn the new technologies, not hesitant to develop. So yeah, Java is catching up, and that's a tough thing, because if I ask all of you what version of Java is the latest version of Java, and I will leave this question hanging for 3 seconds. I'm pretty sure that a lot of you did not answer Java 17. And I'm pretty sure that a lot of you are also stuck with much older versions of Java. So the problem is that Java has started innovating quite a bit faster in the past couple of years. I don't think it will ever catch up with the pace of Kotlin, and that JetBrains is very focused, has a very focused development team behind Kotlin. And of course, there isn't so much backwards compatibility, and there aren't just as many considerations that the designers of Java have to make. But the idea is that maybe in the future, Java will implement most of the things that Kotlin has that make it so nice. And what will be the point of writing Kotlin then? Since Java is the established and dominant language. So that's a concern that some people have. Some of you may remember the language called Coffeescript. So JavaScript used to be very bad back in the day, and there was a language called Coffeescript, which basically had the same exact promise that Kotlin has against Java. And then ES6 came around, and TypeScript came around, and I think everyone who knows where Coffeescript is right now would see this as a cautionary tale. Many of Kotlin's improvements can be implemented as Java as well. So basically, the idea is that if you're actually writing stuff in Java, because that's what we're comparing Kotlin to, and if you're willing to make the effort to switch your team to a completely new language, then you may just take the effort to implement static checking and implement rigorous use of optionals and implement some rigorous code style that will actually make the improvements in Java quite similar to what you would get by using Kotlin. This I don't really agree with. I think Kotlin is not only an improvement in terms of utility. Kotlin is a change in mentality, so it adopts the functional programming mindset in a kind of hybrid manner with the object-oriented programming mindset. And Java is probably never going to implement it to such an extent, but this can be an argument that for some teams that maybe we should just put more effort into writing nice and more maintainable Java code. And tooling is actually inferior to Java. So even though JetBrains and Kotlin are basically the same entity, IDEA is still better for Java. That's a fact I would personally agree with, and many people will tell you that writing Java is easier in IntelliJ, for example. Now, Kotlin also does some things quite awkwardly. For example, the fact that you can have many classes per file. You can have so you have these things called companion objects, which are an interesting topic in and of itself, the philosophy behind them. But basically, you cannot have static fields in classes. You have this thing called the companion object, which is a bit clumsy at times. For example, data classes are final and cannot extend other classes, which is a serious limitation for some people. Of course, this is not a real limitation of data classes, because that's just the way they were designed. But it makes them not so versatile. Null safety isn't so pretty in that I just showed you the very nice handling of null values, but what I did show you was pure Kotlin code. Most Kotlin code in the real world will need to interface with Java code, will need to use Java libraries, and null safety in Kotlin code that uses Java code isn't so pretty. I don't want to elaborate on that too much, but the truth of the matter is, it does get a bit messy sometimes, and the complete null safety is sometimes not preserved if you have to use Java classes. And the last point is that Kotlin has way higher complexity than Java, and I think that's an important point. Kotlin is a much more powerful language that will allow you to write a lot more concise code, a lot more expressive code, but it does have a lot of features as well. I did show you the collections library. It's huge in and of itself, and Kotlin then has all these shifting paradigms compared to Java. So there is an idea that Kotlin can be a 10 times language for 10 times developers. So for your average Java developer who is very used to the Java way of doing things, it might be a hard pill to swallow, and it might be a bit too difficult to embrace. I'm not so sure about that as well, but some people do think that this is the case. I do think that Kotlin can get complicated. I do think that Kotlin code, if you're going full on functional programming, I think Kotlin can get complicated for an average Java developer and can be difficult to understand. And basically, that's all I had to say. So I'll just leave you hanging. I will not give you a clear conclusion about a clear rebuttal for the arguments for or against. After all, you have to make up your own mind about Kotlin. I was very happy to talk to you today. Thanks again for VMPL, for the platform, and remember that we are hiring. So we're looking for Java developers and others. So if you're looking for something else, feel free to reach out. And now, if you have questions, I will try to provide answers. How does Kotlin in Spring work? As good as with Java, or are there any drawbacks of Kotlin? There are some things that you need to do to make Kotlin work nice with Spring. I would say with Java EE as well. In general, as I said, Kotlin has first-class support from Spring Boot. There are many examples. So if you go to the Spring Boot documentation, most of the examples, if not all of them already, are translated into Kotlin. And you will not have any trouble setting up a project with pure Kotlin, with pure Gradle and Kotlin in Spring Boot. So that is very well. I would say this isn't something that should stop you from adopting Kotlin. That you're afraid of the way it works with Java. With Spring. Yeah. So there's another question. I would expand that to all Java frameworks. Is it a common thing to adopt Java frameworks into Kotlin, or to use its own frameworks? There are quite a few. So if you're talking about the major frameworks, the major web frameworks, I'm not actually competent to talk about Android things. I can talk about web frameworks. So Kotlin does use Java frameworks quite a bit, although there are Kotlin-specific frameworks. There are even frameworks like Javelin, which is a new thing that's come out in the recent times, which are specifically, Javelin is Java and Kotlin, which are specifically designed to be easy to access from both languages. There are lots of libraries. Of course, it's already it's a language that's been around for a while, in fact. So there are lots of frameworks that also are natively developed in Kotlin and are meant to be used from Kotlin. Yeah, it is common to adopt Java frameworks into Kotlin because that's what Kotlin was designed to do. Actually, Kotlin was supposed to be, from the beginning, a language that can use Java code, right? The interoperability with Java was supposed to be easy, to be seamless. I would say 99% of the time Kotlin does deliver on that in the cases I've seen personally. Most complaints you will see about the interoperability with Java are about the null values, actually, and some design decisions that Kotlin has, like all the classes are by default sealed. So you have to declare them as open to be able, so that frameworks can use them. This can be fixed with compiler plugins, for example. But most complaints you would see about the interoperability with Java is, for example, about the null values, I would say. But in general, it is common. Yeah. Another question: if Kotlin can be compiled to JS, can it be used as front-end tool language? Yes. Yes, Kotlin can be used. There are projects. I don't think many people are doing it in production these days, but there are frameworks that basically allow you to write. Well, the idea is basically the same as in JavaScript, that you have the same language on the front end and the back end. Kotlin wants to be able to do the same thing, and there are frameworks that allow you to do this. I'm not sure about graphics libraries, so I'm not sure about pure front end, if there's anything Kotlin specific there. So I mean, desktop front ends. I'm not sure if there's anything specific, but in general, I have not used it on front end personally, but the way I followed news about Kotlin, there are some libraries and people are actually writing front ends. So I think there's this, I think there's this thing called Kotlin React, for example. So basically you have these wrappers if you want to even. So that's pretty funny. All right. Thank you very much. Hope you enjoyed the webinar. And as I said, this is the first one in a series of webinars, which we hope to host at VMPL. So see you next time, and thanks for tuning in.